Okay, so chords 10.3. Done with Elvis for a second. Maybe we'll listen to his songs when we go walk outside. That's what that song was.
Yeah.
Yeah. That was Elvis Presley. Yeah. Okay, chords. Okay, a chord. Let's draw a circle. Guess what? You guys have already been drawing chords, and you just didn't know it. Yep. Okay, a chord. I'm going to hit 1 point. Okay, I'm going to hit 1 point on my circle. And I'm going to draw a line to another point on my circle. That line, what are we looking for? Oh, I don't think there's many. Okay, this line right here, this is a chord. That's it. That line is a chord. A chord is a segment. We have been doing segments. We've been finding the area of segments. This is a segment whose endpoints are on the circle. This is not a radius. This is not a diameter. We are not going through the center. It's just two endpoints, and we're drawing a line to connect it. Thank you. This is a chord. Okay. And then we're going to do another circle. I'm so glad that she stopped in when we were not singing. Perfect timing. Yeah.
She would have been okay with singing. Why does Mr. Hallway always leave when we're here?
Does he hate us?
No, not at all.
I think it's because we found out his
Oh yeah, he probably bakes.
Yeah, like me, I'm definitely listening on the stage.
I think you're lying. I don't think he's like.
I don't think he's 50.
I think he's like 40 something. It's Mrs. Holloway, right? It's like 30 something.
Yeah, Mrs. Holloway isn't that old, so.
So?
Mr. Holloway is going to be 12 years older than her.
Never know.
I mean, like that.
I mean, there's like, okay, what Leo DiCaprio
Okay,
dates like really young women.
he's also like a billionaire.
Okay, okay. Let's draw two chords. Draw two chords.
On the second circle?
Yep, two chords. This is an example. We're going to draw two chords. And then I'm going to draw diameters right through the center to touch these. I just drew two diameters. If that was my center.
Okay.
Two diameters and two chords. My diameters are what color?
Orange?
Orange. And my chords are what color?
Orange. Oh, blue.
Blue. Yep. Okay.
With the smartest guy.
There's a relationship between these two chords right now. I want you to find out what it is.
Hey, it's like the thing we saw today, the bow tie. Bow tie the butterflies. When did
Yes!
you see a bow tie butterflies?
Okay, what about those bow ties and butterflies? Okay, I know, that didn't make any sense to anyone else. Yes, so this part of the bow tie is called what? Radius, right? Yep, and is my radius the same around the circle, or is it change?
Change.
No, okay,
Oh.
yeah, no, it's the same,
Oh.
yep. So this is congruent to what else?
All the other chords?
All the other radius, yep. This radius, this radius, and this radius. Okay. Now I want you to find the relationship between all the chords. The two chords are what color?
Orange.
Blue. Okay.
Chords are blue.
Yep.
So what is the orange again?
Are the diameters, which we cut in half because it went through the center, so they're the radius. Okay. What do they make? What shape do they make? A bow tie. No, not. Don't worry about bow tie. That's just for algebra. They made triangles, right?
Oh.
Okay.
I said that today.
So think about triangles. You got two sides are congruent of these triangles. What else is congruent? Isosceles. It is an isosceles triangle. Yep, but they're both isosceles. Are these triangles congruent? How do you know that? That's just side though.
Size. They share the same midpoint.
Okay. What do we call those angles?
Vertical angle.
Yes, vertical angles. So this one is congruent to this one. So by side, I just call it side angle side. When you guys say like SAS and stuff, I'm like, no clue. So by side angle side, these two triangles are congruent. So that means what about my blue links? Tristan, what does that mean about my blue links? Yeah, the chords. What if these two triangles are congruent, Modelia? What about these two chords? Since they're both in these triangles. Shh. Yes. Yes, congruent. Thank you, Tristan. This side is congruent to this side. So by congruent parts of congruent triangles are congruent, the chords are congruent.
CPCT. What does that mean?
Congruent parts of congruent triangles are congruent.
Oh, that was a.
Yeah, way back when. Yep, we're gonna be proving so much stuff again.
Cool.
Okay, guess what? You guys just proved a theorem without even realizing it. This is theorem 10.3 plus its converse. You're never gonna sit there again. Yeah,
I was teaching.
you're talking. Okay, ready? Theorem 10.3 plus its converse. Ronaldo, what does converse mean?
Converse, like opposite?
Yeah, so if I give you a statement, it means it's an if and only if, so it can go both ways. So if two chords are congruent or in congruent circles, I don't like how this is done. So if two chords are congruent, that's saying like if they're in the same one, they're also going to be congruent. But also if they're in congruent circles,
Wait, what does that say after the first congruent?
are congruent, parentheses,
Oh, okay.
or in congruent circles,
That's what
yeah, it doesn't like those. Okay, I'm sorry. If two chords are in the circle, I'm sorry, or in congruent circles, are congruent, then, which we're going to write as an if and only if because it's a converse. What, Adeline? I had to go back because I didn't like how I was wording it. No, I'm going to write it again, just neater. Then their central angles are also congruent. So we proved the converse up above. And we're going to draw a circle with this guy. A circle? Moana. Hi. So I'm going to draw my two chords here, and let's do it here. If these two are congruent lengths, I'm going to draw my triangles with them. Something like that. This tells us
that first line straight up? Or,
It can be any way. This is just a radius. All radius are congruent, right? Okay, so all my radius are congruent. My theorem is telling us that these two are congruent. The chords are congruent if the central angles are also congruent. So this is also congruent to that. It can go either way. Let's label these. Let's call this A. This will be B. Let's call this C, D. And our circle will be P. AB, that line, that chord, is congruent to which chord? Which line? Yep, CD. Which tell us if and only if angle what, Ronaldo, is congruent to angle what?
CD and AB.
Angles.
Oh, angles. Angle Y is congruent to angle Y is what you just asked me.
Yep, what two angles are congruent if these two chords are congruent? B and D?
AB.
I said that this is congruent to this.
Yeah.
So which two angles are congruent to each other? The central angles.
Oh, P.
It's not. It's a theorem. So what are angles?
It's two different angles. Or well, they're equal.
What is the angle inside this triangle right now?
That's
Okay, so how would you label this angle? I need 3 letters.
oh, APD.
Yes.
Oh,
Is-
that's what you're asking me? But CPD.
Yeah.
Was it that hard?
It's an if and only if statement. It goes both ways. Okay. Next one. Theorem. 10.4 plus its converse. It's still related to this. We're still talking about chords. I have to scooch down for the people. Okay. Let's draw a circle first. Well, it's all circles. This entire chapter is just circles. We are not done. Okay, I'm going to draw my 2 chords. If these 2 chords are congruent, guess what else is congruent?
The gaps.
What do we call these? Arc. Yes. This arc is congruent to the other arc. So this arc is congruent to this arc. This looks like the 70s right now with these colors. It looks like the 70s. Yeah. So if 2 chords, I'm sorry, back it up. If 2 arches in a circle, or in congruent circles, are congruent, then with a double arrow, because the converse is also true, then the chords are congruent. Where?
A circle or one or.
Or.
Oh.
Or. They're also congruent, those chords. And it goes if and only if, so it can go both ways. What, you tired? Oh, there's another one. Okay, do you want to do boardwork? You want to leave time to go outside?
Leave time to go outside.
Okay. Okay, finish this one. Give me a thumbs up when you're done writing. Okay. It's okay. Okay. Thumbs down. We're going on to a third theorem. Those 2 are pretty easy, right? A little bit. Yeah. Pardon? The next theorem. Okay. I'm scooching it up and going over, but you guys stay where you are in your notebooks. Okay, guess what theorem's next? Yes, theorem 10.5 plus, of course, it's converse. What's darn it? Oh.
I'm happy that we're writing.
Plus it's converse. Okay, guess what we're drawing?
Oh, a triangle? A circle?
Yep, another circle. And if today's all about chords, we're also drawing two chords. I'm drawing, oops, there we go. My circles are what they are. They're free-handed. Okay, I got my two chords. And what point did I just draw?
Central?
Center of a circle. Yep. Okay, 10. I mean, it is the midpoint of the diameter. That is true.
You just told me I was right.
Is the midpoint of the diameter. So this statement says that if chords are equal distance, have we talked about that word before? No? Equal or distant. Yeah, what does it mean?
That word's too big.
Yes, I don't know why they decided to put it together. But yes, if chords are equal distance from the center or center of congruent circles, I'm so glad you asked because we're about to draw it. So that means I go from the center and that this pink line is going to be congruent to this pink line as well. Congruent and congruent. And you know what's a really fun fact about this? They form a 90-degree angle always. They always form a 90-degree angle with the chord.
Both sides of it?
Both sides, but inside. So it's above it. So where this chord hits the radius. On
Oh, so it can't
not
be under.
no, it's on this side of it. It's gonna be edged up. So it's always gonna look like this with like something like that. So it's right there and right there. Yep. Okay. So if two chords are equal distance from the center, guess what? They're gonna be congruent. So this is an only if and only if, so double arrows, then they.
What does that sign mean? Only if?
It's if and only if. Then they are congruent. So let's label this a little bit. Let's call this point up here A. Let's call this B, C, D. So I did all my chords. We'll call this F and E. What? So much writing, right? Middle point, let's call it P. So if my two chords, no, the equal distance away. So if EP is congruent to, yep, FP, this tells us that AB is going to be congruent to what? Yep, DC. Let's state the converse of this as well. We'll just flip these. So if
Equal is congruent to DC, then EP is congruent to
yeah, then EP is congruent to FP. We're gonna do a problem together. Or do you want to do it up on the boards?
board.
Okay, boards, you just gotta remember to put it in your notes.
I'd rather just do it here.
Okay, we'll do it here for today. Let's sketch our circle. Another circle. You're gonna get so used to drawing circles. You could probably freehand it at this point.
No.
I can.
Here you go. Oh my gosh. How did I make a bad circle with something to trace? Oh my gosh.
So these are my chords. Now, I have to draw something that shows that they're equal distance away. It's not the radius, but it's equal distance away. So let's draw it here and here.
So wait, is it when it's pointed up towards it? That's how I know that's the inside?
Yes.
So this side's gonna be the 90 degrees?
I'm pretty sure it makes a 90-degree angle
Both sides are 90.
on both sides.
Huh?
Yeah.
Oh, so it doesn't matter what I do.
No, it doesn't matter what you do.
Okay.
It can go on both sides. Okay. I don't even like that chord.
Does it look?
No, it doesn't. Let me change it.
Can you stop?
Okay, add your 90-degree angles to this.
Oh.
So 90 degrees, 90 degrees. I know they don't really look like it, but it's close. Okay, I'm going to tell you that this distance right here is 4. 4. And then I'm going to make a triangle that goes out to here. And I'll call this 5.5. That's my length. Okay.
It obviously is. Go, finish your sentence.
Ronaldo, move back.
Why?
Because you're calling him names. Move back.
Because he deserves it.
Mm-mm.
He deserves it.
We'll call this R S U T, and we'll call the middle P. C. U. What did I say? Okay, let's go with you.
Wait, what?
I don't know. I want you to find length of UT. Find the length of UT. Yep. And I'm going to give you the fact that arch US is congruent to UT arch. Arc.
Wait. US or RS?
RS is congruent to UT. Both of those arcs. Yep. I want you to find the length of UT and RS. Find those two lengths. What's our first thought?
Pythagorean theorem.
Okay. So a squared plus b squared equals c squared. So we're talking about a right triangle. What right triangle are we talking about right now? This one? Okay, we're talking about this one right there. So what is my hypotenuse? 5.5 squared. We'll call this just x for now. X? Okay. So a can be x. So x squared plus what? 4 squared. Okay. Figure out what x equals. Okay. I need someone to second it. Yeah, we got a second? Yep. Okay. Anyone have a question about how we got to this point? No? Okay, so then what is the length of UT?
30.77? 30.
7.54 is 7 point. Like this?
No.
So that line doesn't cut through the middle of all.
Not the middle. No, it does not. What? Yeah. No. Talk to your partners next to you. Figure out what you have to do next.
Can we just put
3.77 plus x.
These are
3.77? How do you know it's 3.77? You thought x was 3.77, yeah. Wait, I'm thinking. Wait, I'm thinking. Yeah. Is it?
No, the radius is 4.
No.
Oh.
Mm-hmm.
Aren't they both in?
Yes. Okay. Yes. Okay. Yep, so what would that be? We're doing 3.77. That's that. And now we said that these were two similar triangles or congruent triangles. So this is going to be the same length. What? 7? 5, 4? Yeah. Okay.
Or the 7.54. And the opposite. And the chords are both equal, right? So RS is the same.
Yep. So since we have equal arches, that implies that our chords are what? Yep, congruent. So then RS would be what? Yep, 7.54. Because they're both the same.